Hello, how are you doing here? It's Mike again, and this video we're going to talk about how to solve rational equations. And I wish I could tell you that there's some sort of formula that I can give you, but however, it's more of an application, and it's a repetitive application that you're going to do pretty much through every single problem. So first of all, I think the best thing for us to do is go try a simple problem, a simple rational equation. Remember, a rational equation is any equation that has a fraction. Is any equation that has a fraction. And specifically, these ones are more particular because they have the variable is in the denominator. So notice here that our t, this is actually a t, it's a t, our t is in the denominator. So our variable is in the denominator. And this could be a t, it could be an x, it could be a p, it could be any variable that you need, but that's specific. But however, a rational equation does not necessarily have to have a variable in the denominator, but in this circumstance it does. What I always like people to do is that I always like to recommend to identify the domain of the problem. And when we look at the domain of the problem, we're looking at each individual part. So notice we have the first fraction, which is just a rational number. So there's no domain issue there. It's all real numbers. The second one is 1/5, and that's also a domain that has all real numbers. So I'll even put that here and put that here so we can see it. And then this last guy, hopefully we can recognize rapidly that t can never be equal to 0, because if t equals to 0, we're going to have a undefined value. It doesn't exist. It can't occur. So in this circumstance, you would say that t cannot equal to 0. And remember, we would determine that by setting our denominator not equal to 0. So it just so happens that all we have to worry about here is just setting the denominator t not equal to 0. We'll advance and do something a little bit more advanced in a second, but I want to start with something a little bit easier at the beginning. So if we get t equaling to 0 as a final solution, we know we must exclude that. So if t equals to 0 is a solution, we must exclude that. We must exclude that because it will never allow this equation to work. So there's a whole theory about why you're going to get these extraneous solutions that will never allow it to work. That will never allow the equation to be solved. But for this video's purpose, all we're going to do is learn how to solve this. So what is our trick? What is our trick? Our trick is to multiply through by the GCF. Multiply through by the GCF. So we have a 4, we have a 5, sorry, by the LCD, not by the GCF, but by the LCD. So the least common denominator. So, even if you don't recognize the lowest or the least common denominator, any common denominator will work. So let us look at this. We have a 5 and a 4. The least common factor shared between 5 and 4 is going to be a value of 20, and then we're left with a t at the end. And we are guaranteed an LCD if we want to just multiply our values together. So if we had 4 times 5 times t, we know that we would have a common denominator, a common factor between our denominators to be a value of 20t. It may not be the lowest one, but for our purposes, it will reduce at the end. So I have 1/4 plus 1/5 plus 1 over t, and I'm going to multiply through by a value of 20t. There's going to be an intermediate step here that some people don't show, and that's okay. It depends on how particular your instructor is or how much you want to show for review later on. But all we're going to do here is that if we're going to multiply through by a value of 20t, we have to distribute it to all three of these terms on both sides of the equation. So we're going to have 1 times 20t, which is going to be 20t all over 4, plus we're going to have another 20t, a 20t all over 5, because 1 times 20t gives you a value of 20t. And this is going to equal to 20t, because 1 times 20t gives you that value of 20t again. And this is going to be all over a value of t. And now we're just going to cancel any common factors. We're going to cancel any common factors. And notice our denominators are going to disappear when we do this. So in this circumstance, I'll cancel in gray. 4 goes into 4 once, 4 goes into 25 times, 5 goes into 5 once, 5 goes into 4 times, and t goes into t once, and t goes into this t a value of 1 as well. So this will simplify into 5t plus 4t equals a value of 20. 5t plus 4t equals to a value of 20. And these two are similar. These two are similar. And for all purposes, these two can be considered the same. They can be considered the same. I know which one I'd rather solve, and that'd probably be the second one. But they are pretty much the same exact equation. They might be a little bit different. I'm going to show you in a second how they would differ. So now since we have 5t plus 4t, this will give us a value of 9t equals to a value of 20, and divide both sides by 9, and we would get t equals to 29s. And then we have to check our original domain, check our domain of the problem. Check our domain of the problem. And remember, our domain of the problem was that t cannot equal to 0. T cannot equal to 0. And by us getting a value of 29, so we know that it's not a value of 0, so that is a sufficient answer. Let's go ahead and try another example question. Let us try another example question that's a little bit different. Let us try the equation. 5 all over 3x plus 2, this is set equal to 3 all over 2x. So first of all, I always recommend identifying the domain of the problem. So the domain of the problem is going to be determined by setting the denominators of each one of these terms not equal to 0. So here we're going to set 3x plus 2 not equal to 0 because we can never have a 0 in the denominator. We're going to subtract 2 on both sides. So we get 3x cannot equal to negative 2, and then divide both sides by a value of 3. So we get x cannot equal to a value of 2/3, which means that if we were to get negative 2/3 as a solution after we solve this, we have to exclude it from our solution value. So now we're going to do the same thing over here with our second term. We're going to set the value of 2x not equal to 0. And we divide both sides by a value of 2, and we get x cannot equal to a value of 0. 0 divided by 2 is a value of 0. So our domain of our problem is x such that x cannot equal to negative 2/3 and 0. So if we were to get those two solutions, either one of those or both, we must exclude that from our original domain. So now we have to find the LCD. I'm sorry, the least common denominator. I'm having an issue with my LCDs and GCFs, all my acronyms. But our LCD can be determined by multiplying this denominator by this denominator. We're guaranteed a common denominator if we multiply the two together. So I'm going to have 3x plus 2 kept in a set of parentheses and a value of 2x kept in another set of parentheses. And since we're multiplying them, I would recommend not distributing. Do not fold them out because ultimately I'm going to cancel these terms. So in this example, I'm going to take 5 all over 3x plus 2, and I'm going to set this equal to 3 all over 2x. I'm going to show another intermediate step again, which is going to be me multiplying through by that LCD of 3x plus 2 times a value of 2x. Some people don't show this, however, I do. We're going to distribute it to both sides of the equation. And this will give us 5 still all over 3x plus 2, and that's going to equal to 3x plus 2 times a value of 2x. And this will be set equal to 3 all over a value of 2x. And this will be multiplied times 3x plus 2 times a value of 2x. And some of you may think, oh, this is just like cross-multiplying. In essence, this is cross-multiplying. This is something that we did not learn growing up because multiplying through by the LCD is a little bit more complex than just saying cross-multiply. So notice in this circumstance, our 3x plus 2 will cancel with this 3x plus 2, and then our 2x will cancel with this 2x. So we're going to be left with 5 times 2x, and that's going to be equal to a value of 3 times 3x plus 2. 3 times 3x plus 2. Oops. So this will give us a value of 10x, and that'll equal to, we have to distribute our 3 to both of these terms, so we're going to have 9x plus 6, and then we're going to subtract 9x on both sides, and then we get x is equal to a value of 6. And then we must cross-reference this with our original domain. And remember, our domain at the beginning said that x cannot equal to negative 2/3, so we're safe there, and x cannot equal to 0, so we're safe there as well. In essence, actually what we could do with every single one of these equations is that we can always check our answer. So if we had 5 all over 3x plus 2, we set this equal to 3 all over 2x. You can always plug in the value that you got to determine if it works. So we're going to have 5 all over 3 times 6 plus 2. That has to equal to 3 all over 2 times x, but x was a value of 6. And this will give us 5 all over 18 plus 2 gives us a value of 18 plus 2 gives a value of 20. 18 plus 2 gives a value of 20, and this will give us a value of 3 all over 12. 5 and 20 both share a common factor of 5, so this reduces to 1/4. 3 and 12 also share a common factor of 3, so this will reduce to 1/4. So notice we get a true statement, which means that x equals to 6 is a valid solution and it does not violate the constraints of our original problem.